So we are going to solve one Leetcode problem in this video, and this is house robber. Yeah, uh, this is dynamic programming problem. You can think greedily, but at the end you will not get the result. What that that you are asked in this problem, because you will not get the correct answer at each and every test case if you solve it greedily. So basically, we'll solve it by using different approach. Like in DP you have to learn the recursive approach. First you have to solve it by recursive, and then you have to memorize in order to reduce the time complexity, and then tabulate it in order to reduce the space complexity. So we'll do each and every approach in this video. Okay, so before solving this problem I would like to tell you one DP concept. One DP concept. What I would like to tell you something that you should know before solving these problems. Like uh, yeah, we should start. Uh, so this is this type of problem. What I think you have read this the statement of this problem, that you are a professional robber, and then you are planning to rob a house, and you have to rob a house in such a way that it will not be robbed adjacently. Like you can't rob if suppose this house at index 1 is robbed, then you can't rob the house at index 2. If it is robbed, then you can't rob at house of index 3. So in this way you have to rob the house, and and at the end you have to find what is the maximum, what is the maximum money that, or what is the maximum amount na? Yeah, it was money you can rob, you can rob. So if I will, so what is the concept, this problem is based on one pattern of DP, that is subsequence pattern of subsequence pattern. And you should know what is the way to solve this type of problem. What is the way to solve this type of problem? Like you are given a lot of number, uh, suppose it 2 3 4 9, uh, rather take 7. So this is the money in the, according to this problem, this is the money that you have to given in an array na. And you have to find, you have to rob the maximum money at the end of the night, that you have to take the maximum, the sum that you can rob. So what will be the maximum, how you can find? If you will, if you are thinking the greedy, then you are not going to get the, you are not going to get the result that that is asked in this problem, because you will stick to a particular situation, not every situation, but this is a situational problem, or this is the problem, and we have to consider all the cases, and among all the cases you have to find the maximum that you can get. So what is the concept that you should know before solving this problem? That if you are at particular index I, if you are at a particular index I, then you should perform the two type of tasks, like take it, or not take it, take it or not take it. These two type of tasks which we have to perform at each and every index, and then we have to find the best possible cases, or best possible way to get best possible sum, or we can say maximum sum. Okay, so we will, in this problem, in this case which I have taken, like 2 3 4 9 7, if I am taking this 7, then according to problem, then we can't take 9. If I'm not taking 7, you can take 9. So if I am taking a particular index, I have to shift two index before, two index uh, before that particular index. Like if I'm taking this index 0 1 2 3 and 4, if I am at 4 index, then I have to shift two index before 4, that is 2. I will not take 3, I can't take 3. So this is the crux of this problem. If I'm not taking this, if I'm not taking this 7, I will have to shift only one index, because if I am not taking 7, then I can take 9. That is, I will shift to index, I will jump to index 3. In this way, we can think, uh, and let's see one of the best thing that you should know. What if I am at index that is less than 0? What if I am at the index that is less than 0? How you can tackle this condition or this cases, if it is recording or not? Yeah, it is recording. So if how you will tackle this case ki if you are at index less than 0? Yeah, this is the cases that that is important in this type of the problem that you are solving. If you are less than 0, then you have to you have to think ki what we should return. In this case in particular problem, if you are at index less than 0, you can't solve anything. Simply, you can't take any money from there. Then what we have to return? We have to return 0. We have to return 0. Got it? So so this is the crux that we should know, that we should know. Suppose if I am this I should die run I should write on the cases like, let me erase all the thing. Suppose if I am at this index, uh, if I am at particular index, uh, what 4, and I am not taking it, then where should I go? We should go to this index. I'm not taking it, then we can take the previous index. Well, I'm not taking the particular index, then we can take the previous index. If I'm taking it, then where should I go? I will have to go at index 2. This is the recursion tree that I'm doing here. So if I'm not taking this, then what sum I have got from here? That is 0. 0. And if I'm taking it, then what sum I got from here? That is plus 7. Okay. So if I am suppose uh, at this particular index 3, I have to perform two cases. Either I can take it, or I cannot take it. If I am not taking it, then where should I go? I should have to go at index 2. If I am taking it, then where should I go? I should go to index 1. Okay. And in return, what sum I got from here? If I am not taking, then 0. If I am taking the index 3, then what sum I will get? 0, 1, 2, 3 plus 9. Okay. So from 2, what we will have to perform? What we'll have to perform? We have to perform two cases. Either take it or not take it. So if I am at index 2, if I'm not taking it, then where should I go? Where I should go to index 1. And if I'm taking it, where should I go? I should go directly to index 0. And return what sum I got. I got the 0 in this case, and uh 0, 1, 2, 4 in this case. And suppose if you are at index 1, then what operation you have to perform? Again, you have to perform those two type of cases, that is take it or not take it. If I'm not taking it, then where should I go? I should go to 0. I should go to 0. And if I'm taking it, then where should I go? I have to go to index -1. And if I'm not taking it, then what sum I got? That is 0. That is 0. And if I'm taking it, then what sum I got? That is plus 3. So if I'm at 0, then what operation can we perform? Again, two operation: take it and not take it. If I'm taking the particular index 0, then what sum I go? Not taking it, then yeah, I will go to index -1. And and somewhat some that is 0 plus 0. Okay, if I'm not getting it, I'm not taking it, then where should I go? We should go to index minus 2 with sum that is 2. In uh, in starting I have discussed the base case. The base case was that we can't drop anything if we are at the index less than 0. So what sum we will get at in that case, directly we will get 0. So it will return 0 to this f of 0, and from here minus 2 it will also return 0 plus 2 to this case. So what is the maximum among 0 and 2? 2. Okay, you will get 2 from this both the tree. Similarly, what you will get from here, f of minus 1, it will return 0. 0 plus 3, 3. What is the maximum among these two? 3. Obviously it will return 3. F of 1 will return 3. What the what 3? Then 3 plus 0 and f of 0, then see, we have calculated the value of f of 0. What was it? It was the 2. So yeah, further we will learn how to memorize the code. So this is the memorization actually. If we have completed the value of particular index, then we should not calculate it uh, again, because this will nothing but it will increase your complexity of your code. So if you have calculated f of 0, then we should not calculate the f of 0 here. What was the result from f of 0? It is 2. 2 plus 4, that is 6, and maximum of 3 plus 6, 3 comma 6, 6 you will get. 6 you will get at index f of 2. F of 2 is returning 6. 6. So what f of 1, have you calculated f of 1? Yeah, we have calculated f of 1, that is 3. So this function will return 3, and 3 plus 9, 12. 12. What is the maximum among 12 comma 6? 12. Obviously 12. So here f of 3, 3 you are getting 12. So what f of 2, we should calculate the value of f of 2? No, because we have calculated the value of f of 2 where? Here. And what is the value of f of 2? That is 6. 6. So here it will return 6. So what is the maximum of this 12 and 6? Obviously 12. So maximum what is the maximum that you can get? 12 in this case. 12 in this case. Is it right? No, we can get another case too. Oh, shit. 6. See. Here, f of 2 is returning 6. 6 plus 7, that is 13. 6 plus 7, that is 13. 13. So, what is the maximum? What is the maximum of this 12 and 13? That is 13. So, what the sum that you are getting from this array, the maximum sum that you can get from this array, following the condition given in the question, is 13. So, you see, this is the recursive tree that we can draw in this particular problem. So can we jump directly to the coding part now? Because we have completed the everything. We have learned the concept of memorization rather in this tree diagram. Like we don't have to calculate the value of 0 because it was calculated before. We don't have to calculate the value of 2 because it was calculated before. We don't have to calculate the value of 1 because it was calculated before. So this was the memorization that we can say. So now we should directly jump to the coding part now. Okay, so first of all I will write the recursive code, and then we'll see. So can we now discuss the time complexity of this type of code? What is the time complexity? Yeah, I should write here rather. Yeah, what is the time complexity in this code? Initially 2 to the power n. If you will not memorize, then the time complexity of this code is approximately equal to the power n. Not exactly, but yeah, near approx to the power n. But if we memorize the code, it will reduce to the big of n. And obviously, the big of n is what we can run the code up to the constant like 1 is 5, or we can say rather 1 is 6 or 1 is 7. We can learn also, we can run also. So there is nothing problem in time complexity, but if you see the space complexity in this type of the code, then let me take one new page. So what is the time complexity? Big of 2 to the power n. Initially, when we write the recursive code, it was the time complexity of recursive code. But since we have reduced, see, uh, we have reduced the case, like we don't have to calculate the value of f of 0 because it was calculated before. And if you will calculate the value of 0, then it will increase, it will directly increase your time complexity and nothing. This is the increment of time complexity only. So here we have reduced the time complexity to big O of n, to big O of n. So if you will do the memoization, then it will reduce to big O of n. It will reduce to big O of n. And space complexity initially in this case, space complexity was big O of n, big O of n, due to what? Due to recursive stack space, recursive call stack space. Now, but if I will say, see, space complexity was good, but time complexity was not good. If I will see what is the space complexity in this case, if after doing memoization, we'll get the time complexity of additional space complexity of DP array, that will store the value of each and every index, and that will be the big O of n. And again, that is the recursive stack space, that is big O of n. So here in this case, space complexity has increased. So we'll do space optimization in this case also. We'll do space optimization in this also in this case also, and will not use this extra space of recursive stack. Now we'll use only this big O of n. So come on, uh, now we should do the coding part and solve the problem. Like in this problem, first of all, I will write the recursive code. Okay, so yeah, nums- okay, so recursive code. So I have to take one index and then this vector array. Yeah. Then base case. Let me. I will come to base case further. Okay. First of all, I want to write the cases, like at at particular index we have two cases. Rather take it, either take it or not take it. If I will not take it, first I want to solve this. Not take it, not take. Then what the sum will get? 0. And where we have to go? We have to go directly index minus 1 and then nums. Okay. What if I am taking the particular index? Then what sum I will get? Nums of ind, and where I have to go? I have to go ind minus 2, comma nums, comma nums. And then what I have to return? Return this maximum of this both of the cases, that is take, comma not take. Okay. Uh, this was well, maximum take, comma not take. This was nothing but what we have did here. Like uh, we are finding now. Yeah, see here the maximum of these two, uh, 12 and 13. Like, so see here it was the cases of not take, and here it was the cases of take. So we had found, we had taken the maximum of these cases, and maximum of these and these cases, maximum among these two cases. So it was 0 plus 2, and it was the maximum was 2. So we got the answer. So this is the code for that. They return the maximum of take, comma not take. So what will be our best case? If ind is less than 0, if ind is less than 0, then what? Return 0. Simple. Return 0, will not get any the sum from there. So what this will we have to return this f of n minus 1, common nums. Yeah, let's see. Yeah, it is running good. Sweden submitting the code. Let's see what happens. Yeah, we are getting time complexity. Why time complexity? Because I already said you he will get this TLE in bigger cases. So so how you will tackle this? For this, you have to memorize the code. For the memorization, you have to create one DP array vector uh, DP of n, and you have to pass this vector in each and every functions uh, by reference and DP. Yeah. So you have to think one thing in this case, what you have to fill this DP whole DP vector with a particular number that you will never get in this whole operation of these cases like take not take, take or not take. You'll never get the answer equal to this number. You have to assign whole DP with this number. So what number that will not get in all the cases? Yeah, obviously, any negative number we can't get because every sum should be in the positive. Should be in the positive because some money cannot be negative. So, uh, we should. So I'm assigning this the every dex with suppose -2. And if dp of handy not equal to dp of handy not equal to -2 not equal to -2, sorry, -2, return 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 dp of handy. Okay, and then here dp of Andy, dp of what I'm writing here, dp of Andy is equal to maximum of tech common or tech. So here also you should pass this dp in the function. Okay, let me see. Yeah, dp compilation error. Oh, shit. Yeah, it is working fine. Let me submit it. See, you are getting your solution is among 61%. That is not the unique. That is not the unique. That is not the unique. That then what we have to do? We have to do something unique. Like not in this case. Yeah, we have to reduce this space. We have to reduce this space complexity, uh, extra space complexity. We had talked about initially in this video. At the end of this video, the big of n. Okay. So what we'll do? In order to reduce the complexity, we have to tabulate the code because we don't have to do any recursive operation because recursive operation was taking in this extra space that is big of n. So to reduce the complexity of the space, we have to tabulate the code and we have to run only dp array. So how we can do that? See, this is top down dp. This is top down dp from index from where I am coming. I am coming from index of n minus 1, and tabulation is from bottom up. We have to go from index 0 to index this n or n minus 1. So what we had did in this recursive code, we have to do just opposite. That if you have written this base case for what, if index less than 0, then return 0. Yeah, I will tackle this problem. First of all, let me tell you key. uh, yeah, see, we don't have to do anything. If you have think you have if you are done with this recursive code, in order to tabulate the code, we don't have to do anything extra. You just have to analyze this code, and you have to you have to uh, uh, you have to this reduce the recursive extra space. So in this case, in the best case, which if index is less than 0, then we'll get the 0. So how you will tackle this? See, suppose I am assigning this dp of 0 is equal to max of 0. Why I am assigning? You will see the jadoo. So I am iterating from index I is equal to 1. I am explaining you less than n or I plus plus. what you have written, if it is less than 0, then we just have to return 0. Or we can say, if it is in the case of take, then we have to return this, we have to return this nums of id, and not this. We can't do anything this in this case. If it is less than 0, we don't we can't do anything in this case, because there is no any existence of minus 2 index. Or we can say in this case, minus 2 minus 1 minus 2 plus 1, that is minus 1. So if it is, if I less than, if I less than 1, I if I no, sorry, uh, if I less than 1, if I less than 1, then what we have to do? Or less than, or rather equal to 1, rather equal to 1, then what we can do? We cannot perform the not take portion in uh, either we can write some in some other way, like, see, intake initially, intake is equal to this nums of I. Yeah, we can take the nums of I, but we can't take the extra sum of dp of I and d minus 2. If I is greater than 1, if I is strictly greater than 1, then we can take, yeah, take plus n is equal to what, dp of I minus 2. But there is no any effect of this not take. And not take, if you'll think about, if you'll think it clearly, then there is no any effect. You can take it any any in any cases. And then dp of I is equal to what? Dp of I is equal to maximum of take comma not take comma not not take. And then what you have to return this, just modify it, dp of n minus 1, and done, and we're done. So let me run it, what I'm getting. Yeah, this is the correct answer. Mm. See, here you are again at 61% of the solution. Anyhow, I don't know how they are running, but beats 100% of the C++ code. And initially, let me see all the submission uh, when I had submitted previously. Then we will see. Yeah, and that's both code was good. So yeah, I'm done with this problem, and I think you enjoy this video. So thanks a lot. Thank you.